Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to talk about jet engine types. So let's dive right into it. Well, first you have to understand one core aspect. This is part 2 of my first video, and jet engine is inherently a very dynamic system. Well, when you look closely, almost every system is a dynamic system, but here efficiency is the key. Now why is that important? Well, to move an aeroplane that is like as heavy as 200 tons, you're gonna need a lot of energy, and you're gonna get your energy from basically from your chemical fuels. Now chemical fuels will give you 100% of the energy. It's just that can you convert them into useful energy? That's up to you. To give you a context, when you burn petrol in your petrol engine, you're getting all the energy it has. Like petrol is releasing 100%, but only 20% is going to your wheels. Why does that matter? Well, think of this way. What is happening to that 80%? That 80% is heating up your engine block. That 80% is going out as a basically vibration, as a noise pollution. All of them is degrading your engine life. So think of this way, like your car engine has a certain amount of energy, and it has to handle certain amount of waste energy. Now if you can reduce the waste energy, basically, yeah, if I need 1 megawatt from my chemical fuel, I'm gonna burn 1.2, so you have to only handle 0.2. That is why people want to make it more efficient. It's not with mileage and all that. Again, those things are also valuable, because ideally you do not want to refuel mid-air. It can be done, it's just very tedious and very expensive. You just don't want to. Efficiency is the key. Then you will notice that jet engine comes in all shapes and sizes. So sometimes you will have as huge as a dude, or sometimes you will have as small as a dude's arm. So what does that translate to? Like, how does that affect the core dynamics of the engine? The everything about the engine is in one shaft. Like, that shaft is rotating, so RPM is the main factor. So RPM on a smaller one will be obviously higher, and on the larger one it will be obviously lower. That is the main difference. Like, that's the core reason why jet engine, even though smaller than a jumbo jet, still sounds much more louder. The higher RPMs have a different tone to it. You can easily make sense. Yeah, that's a fighter jet versus that's a jumbo jet. And then you have to understand, these systems are built the same way as any other engines. They are sometimes built for maximum power, like a fighter jet. So they will be very inefficient. To give you a context, most fighter jet can go supersonic, but they rarely do, simply because to do that they will burn up fuel so quickly they will run out of fuel. So it will be like, let's say America launches the plane will go next to the enemy border, and then once they are about to enter then they will start the basically afterburners, so they get quick sprint. They can't do that. Only few planes can actually sustain Mach 2 speed in terms of fuel consumption. One of them would be Concorde, another one would be SR-71. So that's the reality of it. Like, if you want the maximum move, forget about your fuel efficiency. Then you want basically low thrust. It's like, I got this. Like C-32 carrier or class aircrafts. You're like, I got this. I just have to move from point A to point B. You're gonna get very high efficiency. So it's a very dynamic system. Now RPM, when we are talking about, because everything is in one core and everything is rotating in one direction generally, RPM is the key here. Now compressor, basically the puppy that is compressing the air and giving you the ability to burn liters of fuel per second. It's like, yeah bro, I need high RPM. The higher the RPM, the better I get. That's the one core advantage of axial compressor. You want as high RPM as possible. Then you come to the fan. Basically, whenever you see jumbo jets, you are seeing what we classify as turbo fan engines. Basically, there is a giant fan. That fan is acting as a cooling system and adding additional thrust and reducing noise also. However, the fan does not want to spin very fast. Now, like, why? Isn't faster better? Well, yes, but side effect is, because of the larger diameter, the tips will end up going supersonic. Now, I'm like, isn't that awesome? Well, no. Why? Supersonic simply means shockwave. Shockwave simply means excess drag. Excess drag means low fuel efficiency. So you're already back to the square one. So that is why they always want to make sure the tips of the turbine, basically the fan, never reaches a point where it's like, I'm going supersonic. You want to be like, bro, do not touch supersonic. So that is why fan wants to be in lower RPM, and it also drastically reduces the sound. So your sound will go from, okay, my ears are getting destroyed, versus, okay, that's annoying. So people really want lower. And again, airport can be handling as high as 100 aircraft to 500 aircrafts a day. So reducing noise level is necessary. And then you have to understand this aspect also. Even though inherently everything is simple in a jet engine, because all it is just an axial compressor, a combustion chamber, and a turbine. That's it. Inherently, that's all three parts there is to it. However, there are a lot of subsystem, from oil system, from other cooling system, temperature sensors, and all that jazz. Basically, same way how your car engine is just not like engine. Like whenever you open the bonnet, there is hundreds of things like computer systems, temperature system, other things like catalytic converters and all that jazz. So you have so many systems there. Imagine what amount of subsystems these puppies have. They have like huge amount of subsystems, and a starter system alone is like a ludicrously complicated system. So those systems also have to keep up. So let's say you built highest quality precision on your main system, and main system is like, I got this, I'm good. But every subsystem that is attached to it, that keeps breaking down because your RPM is too damn high. Yeah, your engine will be grounded. So that is the reality of it. You have to think of it in this way: how hard my engine is to maintain. Like, can a normal dude maintain it, quote unquote avionics dude, not you and me. So that's the reality here. Basically, wear and tear becomes a very critical aspect. So sometimes you will have this design is awesome, but unmaintainable. People will be like, yeah, that shall not touch this in aviation industry. So that's, I'm talking about engine where you are familiar with. It's just using a thruster. Basically, you're rocketing it. You go back. What about sometimes when you hear jet engine used in a helicopter or jet engine used in a power plant? What about those? Or a tank? Abraham M1 series tank has a jet engine. So how the heck that is happening? Well, you have to understand this, because compared to a normal internal combustion engine is very inefficient. But this puppy is high efficiency. What does that mean? That simply means high power to weight ratio. Basically, if I give you this is 100 kilogram, do whatever you're gonna do, give me energy out of it. A petrol engine, let's say a good basic one, will give you 100 horsepower. If you go horsepower, like turbocharger and then some extra, a bit more. But these puppy 100 kilogram, they can go as high as 1600 horsepower at 1000, basically 100 kilograms. So power to weight ratio is ludicrous, and anything that has to fly, power to weight ratio becomes the primary requirement. So people have to use this. That is why helicopters are so successful nowadays. And high efficiency is again, because your everything is in linear flow. Nothing is going like, okay, I'm gonna suck air in and I'm gonna change the air is coming this way, you're gonna suck it in, you change the directions once, then you're gonna compress it again, you change the direction once, then you're gonna detonate it again, you change the direction again, you have to exhaust it. The more changes you have in your airflow, the least efficient it gets. Here everything, that's it, like air comes in, gets compressed, gets burnt, gets out, no hoo-ha. So that is why efficiency is important, and that efficiency allows this kind of mind-boggling power to weight ratio. Now, turbine is generally the main reason how the heck compressor is running. Compressor requires a lot of energy. Turbine allows that energy. But sometimes, let's say where you want to turn the rotor, you don't want your helicopter to basically become like a jet. So what you do, you have to extract more energy out of that turbine stage. So sometimes turbines, you may have like, okay, we're gonna have normal turbine system. We're not gonna touch it because that's, let's say, taken from a jet engine, jet plane. You don't want to tamper with it. All you will do, you will put a second turbine out of that exhaust, and that will extract most energy out of it. So let's say you got 10 megawatts from your basically chemical energy, 2 megawatt was taken for the running of the compressor, then you have 8 megawatt. Instead of turning that into thrust, which is pushing your aircraft, you'll be like, okay, turn this turbine, basically quote unquote windmill, and you want to try to extract as much as possible. So let's say 8 megawatt is there, you want to try to extract as high as like 7 megawatt out of it, and that 7 megawatt will turn your rotor in a helicopter, it will turn your generator in a turbine power plant. Generally a lot of gas power plants are turbine run. So that is how we're gonna achieve this. And sometimes people did try to, like, there are many reasons for different systems. So sometimes you will have one shaft that is acting as a main drive system, sometimes you will have two systems, because again, different things, different requirements, different size constraints, all of those will affect how the heck you're gonna extract that oomph out of it. Basically, you don't want these puppy to become a thrust engine, you want them to a rotational engine. And gearboxes are generally implemented, generally planetary gearbox, simply because they are much more efficient in terms of size and weight. However, they are ludicrously expensive. So generally gearboxes are used to control the RPM, because again, your jet engine can be like as high as like 5000 RPM. You send 5000 RPM to a giant helicopter rotor, it's like, yeah bro, bye. So that's how we extract rotor energy out of. Basically, we just add either a secondary turbine stage or improve the main turbine and make it much more huge. Now, lubrication. If you are familiar with anything that moves, anything metal, you must be familiar with lubrication, aka your car engine. Now, in car engine, there is a lot of metal on metal contact. Basically, the piston head, you have the piston, you have the metal, and they are doing like this. and it's happening hundreds of times per second. So it's ludicrously degrading to the both of them. Basically, not only piston, it degrades the engine wall itself. So you have to employ a lot of lubrication system, and that is why your engine quote unquote drinks oil also. Oil is not something you put and forget. It's like, yeah, you have to replace it every few thousand kilometers. You have to change the oil filter. Basically, oil becomes a consumable. So how the heck, again, these puppies are barely producing 100 horsepower. How the heck a jet engine is going to handle that? Well, jet engine employs something very unique. No places in jet engine, like unless something very cheap or something like that, most of the places in jet engine employs roller bearings. Why does that matter? Simply because there is no sliding contact. Nothing is sliding. Everything is rolling. So by doing that, by employing these very expensive roller bearings, I have provided a video down below, they reduce the friction to almost negligible. Again, it's not zero. It's just like reduced drastically. Instead of metal and metal contact from crankshaft to cylinder wall and all that, it's almost all gone. So if you check how many horsepower, like horsepower per liter in terms of basically oil consumption, jet engine is like, dude, negligible. So because most of them have roller bearings, on top of that, the whole design is designed in such a way that there is minimum number of surface contacts. Now, primary reason oil is used in aircraft engine is as a cooling system, because the RPMs are so damn high, it's gonna heat that thing up. Now, once you heat the metal up, over time it becomes what you call malleable. The moment it becomes malleable, the ball will dig into the race basically and damage the system. So you want to cool it. The cooling becomes the primary function of oil. Again, in our car engine also, oil acts as a cooling system, sub-cooling system. You may have an independent water cooling system to keep it cool, but again, oil also helps in cooling system. This puppy, oil is primarily used for cooling system. Again, and it gets additional benefit. It's like, think of it this way: oh, we use oil for cooling, we also get lubrication out of it. In engine, it's like we need lubrication, or we might get some cooling out of it. So that's the kind of different system here. Now, heavy oil that is consumed is generally put in a very different way. I have provided the video down below, which is very detailed, and you will understand it in, think of this, the amount of flow these puppies have is huge, because these are generally spray on. They will rarely, dunk anything into oil. It's generally sprayed on. So it reduces the wear and tear on anything, because again, if your bearing is going through a oil sump, it acts as a drag. You don't want that drag. So lubrication system is kind of unique in a jet engine. It does not require as much as you would think. Now, one of the final aspects of jet engine, because if you are familiar with any YouTube comment section, jet engine is like, oh, why didn't you do this, or why didn't you do that, why didn't you do this, or like, oh, this engine is better, or that engine is better. There is two primary reasons 99.99% of the time, that is budget and maintenance. Think of it this way: let's say you buy a plane and you are familiar with your company's history. Companies like, bro, I got this, we must have something that gives us our return in 10 years time. Basically, we can maintain the cost for 10 years. That you're like, okay, good. So you buy something that has 20-year lifespan, and in 10 years you're gonna recover your main capital investment, and next 10 years you're gonna make profit. Everything is good. But let's say you bought Airbus A380. It's so expensive, so damn expensive, that the time required to recover your capital investment goes to 50. Now again, the plane will only run for 20, so your capital, basically your profit margin shrink, and that is why Airbus A380 flopped. So money is the main factor. So many times you will think, oh, this system was so good, like B2 bombers, stealth bombers. Here's the deal: those are now basically no longer ordered. Basically, again, it's back ordered to such a degree that it's ludicrous. But again, army is not offering too much. Why? Because it's too damn expensive for army. Like each model is like, each model is 1.4 billion or something. Space shuttle was at that cost. Basically, they could have done moon mission at that kind of cost, and it's like that ludicrously expensive. Then maintenance becomes a very important thing. So you may have two airlines buying two different engines. Somebody may be buying General Electric engine, somebody might be buying Rolls-Royce engine. Now why would that be? Again, let's say both are the same kind of quote unquote chassis, plane is more or less the same range and all that, but why the heck they have two engines? Shouldn't one be better? Well, simply because they might be offering different things in terms of maintenance. One would be like, Rolls-Royce will be like, I'm gonna give you the most efficient engine, but it requires like, at least 5 people technician to maintain it every airport. Other company would like, bro, I don't care about mileage, we do not have enough staff power to maintain the complicated engine, so give us a simple engine. So it's like, it's our is like 3 to 4% more inefficient, but ours is simple. Dude, you got this. So again, that also plays into the role. So sometimes there are two factors that are working against each other. One of them simplicity, another is efficiency. Higher the efficiency you want, the bigger and more complicated your system gets, and the more simple you get, the more inefficient it becomes. Now, the best example of that is this puppy Rolls-Royce engine used in Airbus A380. I provided the links down below. Now, this puppy has same jet engine. Like it has a fan, it has a compressor, it has a turbine, and that's it. So why is it so complicated? It has three of them. If you have noticed the color differences, it has one fan. Fan likes to run on low RPM. So let's say 3000 RPM. Fan is like, okay, I get this. 3000, I'm cool. Now, to rotate this puppy as 3000, you have a different turbine section. Okay, normal, everything normal so far. However, the compressor stage is like, it's gonna stall at 3000. So it needs at, let's say, 8000. So there is a different turbine to drive that 8000 RPM section. Now, there is a second higher compression stage. The higher the compression, the better fuel burning efficiency you get. So if people want YOLO amounts of compression, so there is one. Again, to drive this as higher RPM at in 12,000 RPM, there is another turbine. So you can understand there is one shaft, and that shaft have three independently rotating things. So basically, you have one shaft, it's rotating at let's say 3000. Another shaft that is rotating at 6000. Another shaft inside that is rotating at 8000 or 12,000, whatever that case may be. So you can understand, even though it's quote unquote simple, it's so complicated. And imagine something going wrong with the bearing. How the heck you gonna replace it? And how the heck you're going to maintain make sure that all bearings are properly lubricated and rolling with each other perfectly, and how the heck you're going to cool that damn thing? So that is the whole reality of it. Many times you may think, oh, it's a bit more expensive. That directly affects the return ROI. So many times people simply flat out not touch it. And other times maintenance becomes an issue. People are like, dude, yeah, your engine has better mileage. Just I can't afford the maintenance that it requires. So people will be like, yeah, I'm better off with let's say my aeroplane does not require that 100 kilometer of extra range that I will get because of the efficiency. I'm going with simpler engine. It's much quicker in ROI, and I don't need 20% team running 24/7 to maintain these beasts. So there is a very serious consideration, and weight and size is always an issue. You don't want, like, let's say a helicopter engine you are building, you're not gonna be like, I'm gonna put like an engine that is size of a tank. The helicopter should be smaller than tank and should have more power. So there is always these sort of trade-offs. Like you get one, you lose some. So that is why even in the same company, even in the same chassis, you will find, hey, this engine is different, this engine is different. These things are tailor-made for budget, for maintenance. So like in case of B-22, those radar absorption coat was so complicated, they required a cooling system. Basically they had to make a fridge, quote unquote, for the giant aeroplanes. Fridge for a giant aeroplane. And you can understand that why it's so expensive and why government is like, bro, I get it, it's extra useless in if I'm gonna destroy a country that has 1970s technology, but again, I can't maintain it. So 1.5 billion. So this is always the hidden reality. This is something that you do not see in National Geography or better. But again, these are always the driving factor. Can you make it? Can you afford it? Can you maintain it? And the third part is the one that generally causes the most amount of confusion. It's like maintenance, people don't think it's too expensive. But again, maintaining, requiring aircraft grade engineers to be like on staff all the time, that's expensive. So this was my part 2 on jet engines. I hope you liked it, learned from it in some depth about jet engines. In that case, I will urge you to press like, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment. Please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.